research involves students. Students of the Civil Engineering Department are evaluating the bending strength of masonry beams. In BCIT's Structural Engineering Lab, the beams are externally reinforced using glass and carbon fiber wraps. These tests are sponsored by the Masonry Institute of BC and ISIS Canada.
This is a not very usual project, since most of our projects are related to design and are done individually by students. This one is done and is sponsored by Masonry Industry, who were interested in doing experimental research.
Lately there has been nothing that's failed a structure for masonry. So what they want to know how big, how small they need certain things to be for them to fail. Also, glass reinforced polymers are relatively new for this type of beam. The biggest thing you normally see in a flexural beam that's again above a door or a window are small cracks that occur, and that's creepy and no one wants to see that, and so on and so forth. So these will strengthen that sort of idea.
And this technology is used extensively in older concrete buildings and seismic repairs. Especially, we don't get a lot of seismic activity up here, but down in the States, on the fault lines down in California, they use a lot more of this type to reinforce damaged columns and still save a structure and not have to knock it down.
Well, our project is a continuation of a previous project from last year. Last year they decided to test 9 masonry beams. Masonry, why it's so exciting is because the code's only about 10 years old compared to all the other ones, which are practically ancient. They made 9 masonry beams and they tested 6. They were expecting to see some shear and some flexural failure. Shear is a cutting force, while flexure is a bending force. Last year, from the 6 beams, 5 failed in shear, so nice big shearing cracks that were formed. 1 failed in flexure. What we want to do is we want to see how these beams handle in flexure. 1 is not enough. So we're going to be retesting 2 of the beams from last year that were tested and 3 of the untested beams. This is a small sample of the glass reinforced polymers that we intend to retrofit our beams with. It's quite impressive and rather thick. Basically what this does is the orientation of the fibers is incredibly important. They can handle tension, that means a pulling force, incredibly well. So what we're going to be doing is we're going to be adding these to the outside of the beams, and when these feel flexure, which we hope they are going to feel, it's going to feel a bending. That's what flexure is, a bending. Again, they'll still have the strength it has right now, but all the problems that it has from the cracks and from the shear will be taken over by the polymers.
The retrofit will involve a crew coming in. We're going to grind the corners off the shear critical end zones so that the corner edges of the masonry beams don't cut through these fibers. And then they'll be applying the first stage of an epoxy, putting on our wrap in 2 different designs. We've made 2 different designs to be able to compare them. And then securing it with anchors, put on the final layer of epoxy, let it set for 24 hours, and it's ready for testing.
101, 102, 104. Look at the horizontal crack opening up.
We've had some cracking in the epoxy, and not too much flexural cracking of the beam thus far. It's loose.
This one is...
This is more fun than Disneyland.
We got a little more crushing of the epoxy. It's pretty much what we expected.
That's going to happen soon, within the next 15 or 20 minutes, and the load should be around 100 kilonewtons. That means 10 tons or higher at the failure, and it's going to be a really big bang.
Personally, I've gained a lot of experience dealing with logistical issues. We have a lot of organizational things going on. We have to coordinate with outside contractors, generating funding, getting our teachers involved, we're working on our communication skills. It's really a team building experience.
It's also very exciting / frustrating sometimes to see all the added bits of information you get from testing, all the yays and the oh no's, and I have to admit it's been a really great experience and I'd do it again.
Research just fills out your education that much more.
You still do calculations so you're blue in the face,
yeah,
but you get to do that much more.
You see it at the end. You see the results at the end. It's a little more fulfilling.